You ever stare at one of those massive polynomial equations and your brain just kind of shuts down? Well, what if I told you there's a secret shortcut? A way to predict exactly where that crazy graph is headed in the long run, no matter how complicated it looks. That's what we're digging into today. It's called the leading term test. Let's do this. So get this. This one idea is the secret mantra for everything we're about to do. In the long run, only one term matters. I know, it sounds way too simple to be true, right? But trust me, this single principle is the key that unlocks the big picture hiding inside all those complicated functions. Okay, so the official fancy name for this whole idea is the leading term test. And what it does is help us figure out a polynomial's end behavior. That's just a mathy way of asking, where are the arms of the graph pointing? Way off the chart to the far left and the far right. So here's the magic. Imagine you've got this monster of a polynomial, something like 2x to the fifth minus 100x to the fourth plus 3. Yeah, in the middle, around the origin, it's going to have all these twists and turns and wiggles. But as you zoom out, as x gets huge, like ridiculously big, positive or negative, the entire function starts to behave exactly like its most powerful part. In this case, that's the 2x to the fifth. It's like all the other terms just become background noise. They pretty much fade into nothing. And here's the craziest part. For any polynomial you can possibly imagine, there are only 4 possible long-term outcomes. That's it. Just 4. And what determines which of those 4 futures the graph will have? Just 2 super simple things about that one leading term. Is its exponent, the degree, even or odd? And is the number in front, the coefficient, positive or negative? That's the whole game. Okay, let's look at this grid. This is basically your cheat sheet for everything. So top left. If the degree is even and the coefficient is positive, just think about a basic x squared parabola. Both arms go up, right? Up and up. Now, what if it's even but negative, like negative x squared? Simple. It flips. Both arms go down and down. Okay, now for the odd degrees. If it's odd and positive, like x cubed, it starts down on the left and shoots up on the right. And finally, if it's odd and negative, it's just the reverse. It starts up on the left and goes down on the right. Seriously. That's it. Those 4 scenarios cover every single polynomial. All right, that's the theory. Theory's cool, but let's actually put this thing to work. We're going to run through a few examples from easy to a little tricky, and you'll see just how fast this is. Okay, here's our first patient. P of x equals 3x to the fourth minus 2x cubed plus 5x minus 7. Now, looking at that, you see a bunch of terms, a lot going on. But we're going to completely ignore all the middle stuff. We're laser focused on just one thing. Step 1, find the leader. Which term has the biggest exponent? Easy, it's 3x to the fourth. Step 2, analyze it. The degree is 4, which is an even number. The coefficient is 3, which is positive. So, what does our little cheat sheet tell us? Even and positive. That means both arms point up. Up on the left, up on the right. Done. See how easy that was? All right, let's try another one. But this time, a little bit of a trick question. Look at this function, f of x equals 100 plus 4x cubed minus 5x to the fifth. The terms are all out of order. So which one is the real leading term here? If you said negative 5x to the fifth, you got it. You got to remember, leading term doesn't mean the one written first. It always means the one with the highest exponent. The power of 5 beats everything else here. That scrambled order is just there to try and throw you off. So now we just run the play. The degree is 5, that's odd. The coefficient is negative 5, that's negative. We look back at our rules. An odd negative leader means the graph is going to start up on the left, do its thing in the middle, and then end up going down on the right. Okay, time to level up. What if you get a polynomial that's already factored, like this one? Now, your first thought might be, oh no, I have to multiply all of this out. But wait, don't do it. There is a much faster way. Here's the shortcut. You don't need the whole expansion. You just need to find the leading term from each little piece and multiply those together. So from the negative 2x part, we grab, well, negative 2x. From x minus 1 squared, the leader inside is x, and that gets squared, so we get x squared. And from x plus 3, the leader is just x. Now multiply our 3 pieces, negative 2x times x squared times x. What does that give us? Negative 2x to the fourth. That's our leading term. And just like that, without all that messy algebra, we found our leading term, negative 2x to the fourth. So let's analyze it. The degree, 4 is even. The coefficient, -2, is negative. Even and negative. We know exactly what that means. Both arms of the graph point down on the left and down on the right. Okay, this test is awesome, but I gotta warn you, there are a couple of common traps that people fall into all the time. Let's go over them real quick so you don't make the same mistakes. This is probably the biggest one, getting confused between adding and multiplying. Look, if you're adding or subtracting terms, like x to the 5 plus x to the 3, you just pick the winner. The highest power wins, so the degree is 5. But if you're multiplying terms, like x to the 5 times x to the 3, you have to add the exponents together. The degree there is 8. Super important difference. All right, trap number 2 is all about signs. It's simple, but people mix it up. The only sign that you care about for this test is the sign of the coefficient. That's the number in front of the x. A negative sign in the exponent, like x to the -2, actually means it's not a polynomial to begin with. So that's a whole different story. Just remember, look at the sign in front, not the sign up top. So at this point, you might be thinking, okay, this is a cool trick for my pre-calculus class, but when am I ever going to use this? Well, you'd be surprised. This exact same way of thinking is at the heart of a huge, super important field, computer science. It's the core idea behind a concept called Big O notation. And all that is a way for programmers to measure how efficient their code is. Basically, it answers the question, if I throw a ton of data at this program, how much slower is it going to get? It's all about predicting performance in the long run. So, a programmer might figure out that their algorithm takes, say, 3n squared plus 50n plus 1,000 milliseconds to run. And look at that, it's basically a polynomial, right? Except instead of x, they use n to represent the amount of data. Now, if n is small, like you're only processing 10 items, then yeah, all those terms matter. But what happens when n gets big? I mean, what happens when n gets really big? What if you're Google and n is a billion? All of a sudden, that 3n squared term just explodes. It becomes so ridiculously huge that the 50n and the 1,000 are like a grain of sand next to a mountain. They become completely irrelevant. Once again, the leading term is the only one that matters. It tells you everything you need to know about how that algorithm will perform at scale. And really, that's the whole point of this. The leading term test isn't just some random rule for math class. It's a powerful way of thinking. It's about learning to spot the single most dominant factor in any system, and knowing that, in the long run, that one factor is going to predict the future, whether that system is a graph, a computer program, or something else entirely. So I'll just leave you with this thought to chew on. What are the leading terms in other areas, in science, in business? How about in your own life? What's the one thing that in the long run will have the biggest impact on where you end up? It's a pretty powerful lens to look through. Thanks for sticking with me on this one.